Alright, so this video is going to be part 2 of our limit comparison test practice. Okay, so again, we want to determine if the series is convergent or divergent using the limit comparison test, and here we have the sum from n equals 1 to infinity of n plus 3 over n times n plus 2. Alright, now this is almost impossible to come up with a comparison if you don't multiply through this n. Alright, I mean, when in doubt, just try to simplify it as much as possible so that comparison becomes a little bit easier. Okay, now what you can do here is multiply this n through, as I said, and when you do that, you get the sum from n equals 1 to infinity of n plus 3 over n squared plus 2n. Alright, and now the comparison becomes a lot more clear, okay? You can get rid of this plus 3, get rid of this plus 2n, okay? Only worry about that n over n squared, right? The highest powers of n on both the top and bottom, okay? When you do that, it's pretty easy to see what you're comparing to. That's going to be the sum from n equals 1 to infinity of n over n squared, also known as 1 over n. Okay, the harmonic series. That's what you're comparing to. Okay, so now that you got through that, which is probably the toughest part of the problem, you can actually do your limit. So we take the limit as n approaches infinity of our a sub n, right, our series, which is this, n plus 3 over n times n plus 2, or you could write n squared plus 2n, right, whatever you want to do, over 1 over n. Okay? Now, this n is going to go to the top, so we'll end up with the limit as n approaches infinity of n times n plus 3 over n squared plus 2n. Now, what we can do here is factor out that n. You know, I know I multiplied it through, but we can factor it out to get that n times n plus 2, and then those n's just cancel right off. Okay, you're left with that n plus 3 over n plus 2, which, of course, the limit of that is just going to be 1. And since that is greater than 0 and it's finite, that's telling you right there that you can use the limit comparison test. Okay, you can say if this series diverges, then this series diverges, or if it converges, then this series converges. Okay, so we know since this series right here diverges, well, this series diverges as well. All right, so this series is divergent by the limit comparison test. All right, so as I said, you know, since this 1 is greater than 0 and it is a finite number, that means that either both these are divergent or they're both convergent, and in this case, they're both divergent because we know that this series is divergent. Now, same idea, but with the series, the sum from n equals 1 to infinity of 1 over 2 to the n minus 7. Okay, now the comparison is a little bit easier to see here. We just eliminate this constant, we get 1 over 2 to the n. Okay, so we're comparing to the sum from n equals 1 to infinity of 1 over 2 to the n. Now, what do we even do with this? I mean, what does this look like to you? Well, that's a geometric series. Okay, so we can rewrite this as the sum from n equals 1 to infinity of, well, we can take this apart and we can do this a little bit quicker now, right? We're pretty comfortable with geometric series at this point. So what we can do is write 1/2 times 1 over 2 to the n minus 1. Now, if that didn't make sense to you, how do we do that? Well, what we can do is break this 2 apart into a 2 times 2 to the n minus 1, because this is a 2 to the first power. When we multiply these together, we need to add the exponents, and we get a 1 minus 1 here, which just gives us n. Okay, and that's that 2 to the n right there. So that's why these are equal, and that's all we did here. All right. So now this is a geometric series. We can figure out if this is convergent or divergent later on, but first we need to figure out if this is a comparison that we can actually use. So we need to take that limit. The limit as n approaches infinity of 1 over 2 to the, 2 to the n minus 7 over, you can just use 1 over 2 to the n. Alright, we can put this 2 to the n up on the top, so we get the limit as n approaches infinity of 2 to the n over 2 to the n minus 7. And now you may be wondering, okay, how do I evaluate a limit like this? This doesn't really, fit. I can't use L'Hopital here. And you're right, but what you have to do is do that dividing trick. You got to divide every single term by 2 to the n. And then it starts to become a little more clear. Take the limit as n approaches infinity of, this is 2 to the n over 2 to the n over 2 to the n over 2 to the n minus 7 over 2 to the n. Okay, this is just 1. This is going to be, well, as n approaches infinity, this gets larger and larger. This fraction is going to be 0. So you get a 1 over 1. This is equal to 1, which is greater than 0. Okay, and that's, of course, the first thing you want to check out. 1 is a finite number, of course, so we're going to be able to use this comparison. Now, what was our rule for geometric series? What makes them convergent or divergent? Well, we need to look at this r right here, our common ratio. Okay, this means everything. And we notice we had a 1/2 here, all right? And for a geometric series to be convergent, r must be greater than -1 and less than 1. Well, is it? 1/2, I mean, yeah, of course it is, right? So this is convergent, which means since this is convergent, this series is also convergent, so this series converges by the limit comparison test. Alright, so that's basically it, alright? The comparison may be the hardest thing that you have to figure out, okay? And here, it's just eliminating a constant. So most of the times these comparisons, aren't really that hard to come up with, okay? And that's just taking a limit, and, well, if that limit gives you a finite number that's greater than 0, great, you know that comparison, you can use it. And we did that in this case. We got that series converges by the limit comparison test. That's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for the limit comparison test, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.